Hello, everyone. This is a review of this course. In this review, so our purpose is to let you remember the important parts of this course, remember the important topics, and also the important topics will help you prepare your final exam. Okay, so here I will list the important topics of each lecture. And for each lecture, I will first use one slide to summarize the most important information in the lecture, and also then I will use two more slides to let you know so what you need to know and what you need to know how to do to prepare for the final exams. Okay. The first lecture is an introduction to software quality assurance. In this lecture, the most important thing is the elements of the software quality assurance system. So we know, so there are several layers of elements, include the pre-project SQA components and the project lifecycle SQA components, and the quality infrastructure components, quality management component, standards, and also finally, the organizational base, such as human components. So these components are different layers. So they consist of the software quality assurance system. And in this term, we cover different components in different lectures. Okay. So what do you need to understand for this lecture? The first one, you need to understand the difference between failures, faults, and errors. And you need to understand the causes of software errors, the definitions of software quality, and the definition of a software quality assurance. And also you need to understand the software quality factors, which is also called software quality attributes. So these quality factors are defined in the McCost model and also the ISO 25010 model. So this ISO 25010 model is covered in lecture 2, okay? And also you need to understand the elements of the SQA system as we already briefly discussed in the previous slides, okay? And you need to understand the difference between verification and validation, and the difference between static and dynamic VV. Okay. And that's it for the first lecture. But the second lecture, the topic is quality standards, quality plan, and testing, right? So the topics covered in this lecture are positioned in the software quality assurance system in this figure. As you can see, the quality plan is positioned in the pre-project SQA components layer, right? The software testing is positioned in the project lifecycle SQA components layer, right? And also we cover standards in this lecture. And what do you need to understand? You need to understand the elements of a quality plan, such as quality goals. And you need to understand objectives and the challenges of software testing. So why we need software testing? So we need to eliminate software defects and also demonstrate the correctness of a software system, increase our confidence, right? The challenges, so why software testing is difficult. And you need to understand the different levels and different types of testing and their purposes. You need to understand different integration strategies and their disadvantages and advantages. It's different, such as bottom-up, top-down integration strategies. And you need to understand the concept of white box testing and black box testing and their advantages and disadvantages. And you need to understand the concept of a land coverage or statement coverage, and branch coverage and path coverage. The concept of a equivalence partition strategy. So the land, branch, path coverage are for white box testing. The equivalence partition strategy is for black box testing. And finally, you need to understand the software testing process. So there is a test planning, test design, and test execution, right? And then you need to know how to define quantitative quality goals for given quality factors. For example, I give you the performance efficiency. Okay, so this one will be covered later. For example, I give you reliability, right? About a quality factor of reliability, or functional correctness, right? I give you a quality factor. So you need to be able to define the quality goals for this quality factor. And also, based on the quality goals, you need to design test cases for these goals, right? To verify the quality goals, you need to have test cases. And also, you need to be able to make quality plans. And you need to be able to design test cases using the equivalence partition strategy. Okay. So some of these parts, I would say all of these parts are either covered in your assignments or in a quizzes. Okay. This is the second lecture. The third lecture is about reviews, inspections, and audits. So yeah, to summarize, we also look at where they stand. So they are positioned in the project lifecycle SQL components, right? So together with software testing and other SQL activities, so they are used in the project lifecycle to ensure that the developed software has a high quality. Okay. So what you need to understand the concept of software reviews and inspections. The advantages and disadvantages of review and inspections, especially when compared to other SQL activities, such as software testing. The concept of software audits. Sorry, there's a typo. The second bullet should be the advantages and disadvantages of review and inspections. Okay. That's it for the third lecture. The fourth lecture, software configuration management. So we also look at where it stands. So it is part of the quality infrastructure components, right? We see there's a configuration management here. So this kind of component, such as configuration management, and also include standards and the quality management components. So they provide the infrastructural support and also the guidelines, the tools to support the project lifecycle SQL components. For example, in order to accomplish testing reviews, so we need software configuration management to integrate testing reviews into this entire software development lifecycle and to speed up the whole development process. Okay, that's why we want to add the software configuration management in the topics of this lecture. Okay, so it is the infrastructure of the a whole software quality assurance system. Okay, so what do you need to understand? So the first one is the concepts of the four fundamental software configuration management activities, including version management, change management, system building, and the release management. So you need to understand what they are, right? And you need to understand the concepts of baseline, code line, branching, and merging. So they are part of the version management, okay? They are the concepts in the version management activity. You need to understand the working mechanism of a centralized version control and a distributed version control. You need to understand the concept of continuous integration, continuous deployment, continuous delivery. Okay. And then you need to know how to set up a continuous integration pipeline for a software project. So I wouldn't let you to do any coding or do any experiments during the final exam, but I may ask you to describe how you will do it, okay, at a high level. This is the fourth lecture. The fifth lecture, software performance engineering. So to summarize, software performance engineering happens at the entire software development lifecycle, from functional requirement gathering to deployment to production environment. Okay, so the performance engineering lifecycle starts from non-functional requirement gathering to design for high performance, to unit performance test and code optimization, to performance test, to monitoring and capacity management. So they correspond to different stages of the software development lifecycle. Okay, and why you need to understand. So first, you need to understand the performance engineering lifecycle, and also you need to understand the performance testing process. You need to first set up your performance test cases, right? Yeah, the details you need to set up, you need to design for it, and you need to execute the performance tests. So the details on the slides of the lecture, okay? And also you need to understand the concept of live user based and driver based test execution, and their advantages and disadvantages. Okay. You need to understand the concepts of profiling methodology, including instrumentation and sampling, and also their advantages and disadvantages. You also need to understand the differences between profiling and performance testing, and their different purposes and how they complement each other. Okay, and then you need to understand how to define performance-related quality goals. For example, I give you the quality factor of performance efficiency. How would you define performance-related quality goals within this quality factor? Okay, and also you need to be able to design performance test cases for the defined performance goals. And you need to be able to set up and perform performance testing and profiling for a software project. I will not ask you to do the performance testing and profiling experiments, but I may ask you I'm ask you to describe how you will do it. Okay. Next lecture is about the software performance models. To summarize, software performance models are formal representations of the software system to capture aspects and information of our performance or non-functional aspects. Okay. So what you need to understand, you need to understand the concepts of different types of performance models, including software execution models, which is also named execution graphs. Okay, you need to understand the concept of system execution models, also named as a queuing network models. To understand the black box performance models, which are typically machine learning based models, sometimes also called data mining based models. Okay, you need to understand the benefits and usage scenarios of different performance models. For example, execution graphs are usually used at an early stage of software development lifecycle, such as the architecture and design stages. So you use execution graphs, you may be able to find you may be able to evaluate different architectures and find the best alternatives, and to exclude the alternatives that cannot satisfy the performance requirements at early stage, right? And you need to know how to analyze an execution graph model. You need to be able to analyze an open queuing network model. So you need to be able to do the calculation. So giving an execution graph model or an open queuing network model, you need to be able to do the calculation to calculate the response time, okay? So next lecture is about software security assurance. To summarize, so in this lecture we study, well, first we discuss the so what are software security issues, right? Especially what are software security vulnerabilities, and we, for example, the OWASP top 10 vulnerabilities covered in our class. You don't need to know all the working mechanism, also all the characteristics of these different vulnerabilities. Okay, and also we covered and we also will practice how to use the static analysis and penetration testing to identify the vulnerabilities. Okay, so this is a summary of this lecture. And what you need to understand, you need to understand the concept of security vulnerabilities. So what are security vulnerabilities, right? And also you need to understand the concept and working mechanism of static analysis and penetration testing. You need to have a high level understanding of how it works, why it works, okay? And you need to understand the advantages and the disadvantages and the usage scenarios of static analysis and penetration testing. And what are the difference, right? So when are they used? And you need to know how to perform static analysis to detect the security issues, and also how to perform penetration testing to detect the security issues. So these are covered in the assignments, okay? So I won't ask you to do the actual experiments, right? I may ask you about how you may do it, right? The next lecture is a SQA measurement. what is accurate measurement? Is about how can we measure test cases? How can we measure the effectiveness of test cases? How do we know a test case is good enough to identify bugs, to cover the code, right? So what you need to understand, the concept of input space coverage, code coverage, and mutation coverage, which is also mutation scores. You need to understand this concept and the purpose and concept of a mutation testing. The working mechanism and process of mutation testing. Okay, you need to understand this. And you need to know how to design test cases that satisfy different coverage criteria. So there's different coverage, this coverage criteria like ACOC, ECC, PWC, and BCC. So they are the coverage criteria related to input space coverage. Okay, and also you need to be able to calculate input space coverage based on its different coverage criteria. Code coverage, so give you a simple code and give you a test scenario. You need to be able to calculate code coverage just for very basic cases, simple cases. You can see the examples in the slides, okay? And also you need to be able to calculate the mutation coverage or mutation scores, okay? You can also find the details in the slides. The next lecture is about software logging. So this slide summarizes the components of a typical logging library or logging framework. Okay, so we can see a typical logging framework will include a logger config, appender, a configuration, layout, right, and others. So what do you need to understand? First, the concept of logging. What is logging, right? And the basic logging components we just mentioned, and also the working mechanisms of log levels. For example, given this configuration and giving this level of this logging statement, whether this logging statement will print log messages at runtime, right? Or like given a configuration, which logging statements will print messages during runtime. Right? Okay. The next topic, the next lecture is about AI ops, artificial intelligence for IT operations. So this figure summarizes, so what is artificial intelligence for IT operations, right? So basically, for example, Gartner defined AIOps as a technique that enhances IT operations through greater insights by combining big data, machine learning, and visualization inputs, right? Inputs during monitoring data, such as logs, metrics, and the output you see different different software engineering or software operational activities, such as anomaly detection, performance analysis, right? And we covered different application scenarios of AIOps in the lecture. Okay, what you need to understand the concept of AIOps, right? Basic concept. And the typical inputs and outputs of AIOps solutions, and the usage scenarios of different types of AIOps solutions. So there are some exercises during the class, so you may get some insight from there. For example, so given a scenario, what types of AIOps solutions would you apply, right? Okay, so here we summarize the different lectures, all the lectures actually, except the invited talk that is not covered in the final exam. Okay. and we highlight the aspects that you need to understand, than the techniques or the skills you need to have to have a good score in the final exam. Okay, and finally, I just want to summarize what kind of techniques and tools that you've learned, or I hope that you have learned during the throughout the course. Okay, techniques, you've learned how to prepare a quality plan, how to prepare test plan, right? How to perform functional performance testing, including writing functional performance test cases. Okay, how to do performance profiling, also performance modeling, static analysis for security vulnerabilities, penetration testing for security vulnerabilities, mutation testing. This is to measure the effectiveness of test cases, and the continuous integration to AI ops, right? AI ops is just covered at a very high level. Here we have a blue color which highlights the techniques that are directly associated with software quality, and other like continuous integration and AI ops, they may not be directly associated with software quality, but they are they are either infrastructure or they are indirectly associated. For example, AI ops can help you to how to say, to improve the operation of your software system, which will also help you uh, increase the quality of your delivered services, right? Also about tools. So I hope you have learned how to use JUnit to perform a basic functional test, JMeter to perform performance testing, and how to use JProfiler to do profiling. You may use other tools, and how to use a Sonar Clouds or Sonar Cube to do static analysis to find the security vulnerabilities, and how to use OWASP ZAP to detect, to perform penetration testing and detect security vulnerabilities, and how to use PIT to mutation testing, and how to measure test coverage using tools such as Yagogo. Right? There are also other tools like Docker, continuous integration tools like Stripe CI, and build tools like Maven that you are expected to have learned during the class, okay, during the course. Still, the tools highlighted in the blue color are the tools that are directly associated with software quality assurance activities, right? And other tools like Docker, CI tools, build tools, they are either infrastructure or they are indirectly associated with software quality. Okay. Okay, that's it for this review, and I hope that you have learned uh, things during the course, especially for these techniques and tools. I hope that you've learned or you have practiced, and if so, you can put them in your CV or resume. So when you are applying for jobs, okay, I think they should be helpful for your job application. So thank you again for attending this course, and also thanks for finishing all the assignments, and I wish and finish the quizzes and attending the classes. I wish you have a good luck during the final exam, and all the best. Thank you very much.